Hi everyone, Instructor Barlow here. This is the third lab in the sequence. This is free fall. Okay. If you haven't gotten to some of the material in the textbook, the labs are meant to kind of go along with the text as far as, to an extent, as far as, being able to follow the material and do the lab. There are equations in the labs for the ones that we haven't gotten to the material yet. So if you have any questions as you go through, feel free to email me. I will be available for Zoom meetings at least twice a week, possibly more, depending upon what people need. We'll talk about that a little bit more. Well, we should have talked about it, on our first night. So the third lab is freefall. The first section of this I want you to do on your own, the first page. There's a couple questions about dropping objects and things like that. So that's something that you can do on your own. We're going to pick up here on page 3, and what we're going to be doing is we're going to be dropping coffee filters from a specific height. You can do this on your own if you have coffee filters and you can measure the distance somehow, whether it's with a tape measure or something else. You can also just follow along here, and we're on page 3, and we're going to be doing number 6 and 7 on page 3 of the lab, where we're going to be dropping the coffee filters. So we're going to drop the coffee filters. We're going to first drop 1, then we're going to drop 2 together, 3 together, and 4 together. We're going to drop them all from 2 meters, and we're going to do it 3 times just to have a nice set of data to go off of. So I'm going to take the camera, and Joe, my son, is going to drop the coffee filters. He's going to first drop 1 filter from 2 meters, which is going to be the top of the meter stick. And we're going to time this, how long it takes for the coffee filter to fall from the ground, from the top of the meter stick to the ground. So what we're going to do is we're going to do a little bit of a countdown, and 3, 2, 1, drop. So that first time was 2.56 seconds for that coffee filter to hit the ground. That's 1 filter. Okay, so we're going to reset the stopwatch, and we're going to do 1 filter again. Just 1. Make sure you have 1 there. Okay, yep. And scoot it kind of over a little bit so it's not interfering with it, so it doesn't hit the top of the meter stick when you drop it. Okay. You ready? 3, 2, 1, drop. So that was 2.48 seconds. And we're going to do this one more time with 1 filter. Then we're going to put 2 filters together and drop them. And ready, 3, 2, 1, drop. That one was 2.71 seconds. So 2.56, 2.48, and 2.71. Now you're going to take 2 coffee filters and kind of put them together, like the way that they're stacked in the packaging. And 3, 2, 1, drop. Now, as you'd expect, it's a little less time. For 2 filters for the first trial, it's 1.67 seconds. 1.67. So let's do it again. And 3, 2, 1, drop. 2.07. And 3, 2, 1, drop. 2.07 again. So now we're going to do 3 filters. Same experiment, but with 3 filters. And 3, 2, 1, drop. 1.35 seconds. And again, 3, 2, 1, drop. 1.45 seconds. And 3, 2, 1, drop. 1.45 seconds again. So now we're going to do 4 filters put together. And 3, 2, 1, drop. 1.35 seconds. Three, 2, 1, drop. Let's do that one again, because that one was actually more time. So I don't know if that was a mistake on my part. 3, 2, 1, drop. 1.38 seconds. 3, 2, 1, drop. And that one was 1.26 seconds. So now what I want Joe to do is take one of those coffee filters and crumple it up into a ball and hold it at 2 meters. So the 1, 2, 3, 4 filters was item number 6 on page 3. Now we're going to do item 7. We're going to take one crumpled up coffee filter, drop it from the height, and measure the time 3 times. So 3, 2, 1, drop. That was 0.54, so 0.54 seconds. 3, 2, 1, drop. 0.65 seconds. 3, 2, 1, drop. 0.68 seconds. So the data is only part of number 6 and 7. For number 6, it asks you to write your data in a table, describe your results, and it also asks you to write a theory for falling coffee filters. The other thing it asks is for item 7, it asks you to compare the times to the non-crumpled filters and explain that difference in time. Okay? So that's the first part before we get to the data tables. Now, what I want you to do is I want you to go through and read the mathematical section and the procedures and how the equations were derived for you. The next part of this, we're going to do the stopwatch timing portion of the lab. The last portion of the lab, we're going to use the computer-based mechanism to measure the time. We're going to use a stopwatch right now to measure the times. So the first thing we're going to drop is a tennis ball. Then we're going to drop a steel ball. Then we're going to drop I thought that we were going to be doing so we're going to just be dropping the tennis ball and the steel ball. And then we're going to be doing the last part is going to be the steel ball, but the computer-based portion of it. So I'm going to give Joe the tennis ball, and just like we did before, we're going to drop it, but we're going to drop it at different heights. And we're going to drop it 5 times for each height. So the first thing we're going to do is we're going to take a look at this. We're going to drop it at a 1/2 meter, which is here. We're going to drop it at 0.75 meters, which is 75 centimeters. We're going to drop it at 100 or 1 meter. We're going to drop it at 1.2 meters, 1.4 meters, and 1.5 meters. So what I'm going to need to do is move my tape here so that we can see where 150 meters is. So each one of these, Joe, what I want you to do is hold the bottom of either the steel ball or the tennis ball, whichever we're doing. Hold the bottom of the ball at 50 meters, and we're going to drop it. Or, I'm sorry, 50 meters. 50 centimeters, which is half a meter. So the first one we're going to do is the tennis ball. Tennis ball at a half a meter, y equals 0.5, and we're going to time it 5 times. Okay? So we're going to get down on the floor here, both of us. And I'm going to take the camera. I'm going to give Joe the ball, and we're going to hold the bottom of the ball at 50 centimeters, which is half a meter. So you need to look at the side and see where the bottom of the ball is. And I'm going to be reporting the results. So the first time at 0.5 meters, which is 50 centimeters, in 3, 2, 1, drop. That's 0.25, 0.25 seconds. And time 2 at 0.5 meters in 3, 2, 1, drop. That's 0.44 seconds. Three, 2, 1, drop. That's 0.42 centimeters. Or yeah, 0.42 seconds, not centimeters. We're measuring time. So that was the third trial. 2 more. So in 3, 2, 1, 0.20 seconds, 0.20. And this is the last one at 0.5 meters. In 3, 2, 1. That was 0.36 seconds. Now for each of these, you're going to do an average time, and then you're going to calculate an accepted value for time using the equations at the beginning of the lab. So now we're going to go up to 0.75 meters, which is 75 centimeters. So the bottom of the ball should be right at 75 centimeters. In 3, 2, 1, go. Oh, let's do that one again. 0.75 meters, which is 75 centimeters. In 3, 2, 1, go. So that one was 0.43, 0.43. And 3, 2, 1, go. 0.35. In 3, 2, 1, go. 0.38. And 3, 2, 1, go. 0.56. 0.56, and this is the last one at 0.75 meters. And 3, 2, 1, go. 0.41 seconds. So now we're going to go up to 100 centimeters, which is 1 meter. In 3, 2, 1, go. 0.35, 0.35. In 3, 2, 1, go. 0.43. 3, 2, 1, go. 0.49. In 3, 2, 1, go. 0.45. And this is the last one at 1 meter. 3, 2, 1, go. 0.38. Now let's go up to 1.2 meters, which is 120 centimeters. In 3, 2, 1, go. 0.58. 3, 2, 1, go. 0.40. 3, 2, 1, go. 0.41. 3, 2, 1. Oh, hang on. 3, 2, 1, go. 0.53. In 3, 2, 1, go. 0.61. So now we're going to go up to 1.4 meters. And 1.4 meters is 140 centimeters. In 3, 2, 1, go. 0.49. 3, 2, 1, go. 0.76. And 3, 2, 1, go. 0.55. In 3, 2, 1, go. 0.70. And 3, 2, 1, go. 0.56. Now we're going to do 1.5 meters, which is 150 centimeters. In 3, 2, 1, go. 0.71. In 3, 2, 1, go. 0.53. In 3, 2, 1, go. 0.61. 3, 2, 1, go. 0.60. Last one. In 3, 2, 1, go. 0.51. Okay. So those are all of our times for the for the tennis ball. Now we're going to do the same heights, but we're going to do it with the steel ball. So we're going to go at 0.5 meter, which is which is 50 centimeters, half a meter, it's 50 centimeters. And we're going to do the same thing. We're going to do 5 trials for each height. So 50 centimeters, half a meter in 3, 2, 1, go. 0.35 in 3, 2, 1, go. 0.48 in 3, 2, 1, go. 0.34 in 3, 2, 1, go. 0.36 in 3, 2, 1, go. 0.22. So now we're going to move up to 75 centimeters, which on the table would be 0.75 meters. 3, 2, 1, go. 0.51. 3, 2, 1, go. 0.37. 3, 2, 1, go. 0.35. 3, 2, 1, go. I think we need to redo that one. I think you let go early. 3, 2, 1, go. 0.3. Let's redo that. 3, 2, 1, go. 0.34. And last one at 75 centimeters or 0.75 meters. 3, 2, 1, go. 0.37. So now we're going to go up to 1 meter, which is 100 centimeters. 3, 2, 1, go. 0.64 in 3, 2, 1, go. 0.48. 3, 2, 1, go. 0.35. 3, 2, 1, go. 0.62. 3, 2, 1, go. 0.48. Going to go up to 1.2 meters, which is 120 centimeters. In 3, 2, 1, go. 0.38 in 3, 2, 1, go. 0.31 in 3, 2, 1, go. 0.51. 3, 2, 1, go. 0.70 in 3, 2, 1, go. 0.53. So that was 1.2. Now we're going to go to 1.4 meters, which is 140 centimeters. In 3, 2, 1, go. 0.41 in 3, 2, 1, go. 0.32. 3, 2, 1, go. 0.67. 3, 2, 1, go. Nope. I I think that one's way off. Let's try that again. 3, 2, 1.
Yeah, it's left.
Whoops. Ready? 3, 2, 1, go. 0.63. 3, 2, 1, go. 0.43. So now we're going to go to the last distance, which is 150 centimeters, which is 1.5 meters. Ready?
Yep.
In 3, 2, 1, go. 0.57. 3, 2, 1, go. 0.54. 3, 2, 1, go. 0.57. 3, 2, 1, go. 0.85. That one doesn't seem right, but we'll go with it. Last one in 3, 2, 1, go. 0.43. Okay, so that is all of the manual timing data that you're going to need for both the tennis ball and the steel ball. So now we're going to do the computer-based timing. So we'll be back in a couple minutes once we have that set up. Okay, so for the last part of the lab, we're going to do the computer-based timing portion of it. So on the 7th page of the lab, it shows you a little picture of the setup that I have right here behind me. Okay, there's a little foot switch down here. There's a little bracket up top here that's metal. So when I clamp the steel ball in it, the computer will know, because it's completing a circuit up here, that as soon as I put a ball in there, that it can start measuring the time once I let go and open that circuit. And then when it hits this foot switch, it will stop the timer. So it'll give me a much more precise time than relying on my reaction time and Joe's reaction time when he hears me say go, and then when I see the ball or hear the ball hit the ground. So now we're going to do it in a little bit more of a precise way. Okay. So the program that we use it's called Pasco Capstone, and this interface talks to this setup. Okay. So on the lab, it walks you through this set of instructions. I'm going to go through that with you real quick. Okay, so the first thing we do is go to hardware setup, and you have a little picture of this adapter that plugs into the computer. Okay, it's called the Science Workshop 750. I have this freefall apparatus plugged into channel 1 on the interface. So up here, I'm going to tell it that in channel 1, I have the freefall adapter. The next thing it tells me to do is I need a way to measure the time. So I need to drag this digits icon over, and I get sort of a blank time reading, but I need to tell it what I want it to measure. I want it to measure time of fall in seconds. So I'm going to select that, and you can see that the units changed to seconds on the screen. Okay. The next thing that you have to do is you have to tell it to start recording, and you'll get a little icon there that it says it's run number 1. Now, if you watch, as soon as I put the steel ball up here, you'll see a time should appear, and it should be very small. It should be like 0.01 seconds or something very small. So if I put this up in here, so you see how it went to 0.09 seconds? So let's try it again. Now I'm going to drop, and 2.71 seconds seems like an awfully long time, so I'm not really trusting that. So I'm going to try it again. I have 0.03, 0.01. I'm going to drop it. 0.33 seconds. Now that I can believe. Okay, so now I'm going to take my data sheet, and on page 8, I'm going to start filling in this data. This distance from the foot switch up to the mechanism that drops the ball is at 0.5 meters or 50 centimeters. So my first time at 0.5 meters is going to be 0.33 seconds. And I'm going to measure 5 times again like I did the last time. Okay? Now when I put this in, it should zero back out. And 0.35 seconds. So that's my second time at half a meter. .32. So if you go back and you look at the data from when I was doing it with a stopwatch, a lot less precise than what I'm getting here. You notice these numbers are very close to each other as opposed to when we were doing it by hand. You know, I was 1/10 or 2/10 of a second off, which doesn't sound like much, but you should see the difference when you calculate your percent differences at the end of the lap. Now, those last 3 trials, I got 0.32 each time. So, a lot more accurate, a lot more precise. Okay? So, those are my 5 times for 0.5 meters. Now I'm going to raise this. So, from the top of the foot switch, I'm going to go up to 0.75 meters, which should be 75 centimeters. Well, not should be, it is 75 centimeters, right? So I want this foot switch to be 75 centimeters above the center of where I'm dropping the ball. So that's 75 centimeters. Do a test drop here. Make sure I'm kind of lined up. And we'll take a look. That should zero back out to something real close to 0, which it does. And I'm getting 0.41 seconds. Second trial at 0.75, 0.39, closer than with a stopwatch. Even though this equipment is a little old, again, 0.39. Much more consistent. As you go through your college career and you do a bunch of other labs, consistent data is a good thing because it tells you at least the process that you're going through. is reasonably consistent. Again, that was 4 trials in a row at 0.39. I'm going to see if I can get one that's different than 0.39, just for some. It's like 5 trials in a row at 0.39. Interesting. Okay, so now what I'm going to do is now I'm going to go to 1 meter. Okay, so I'm going to switch. I'm going to move the foot pedal down to the floor. And I am going to lower there we go. The foot pedal is exactly 1 meter above. Now I'm going to come over here and kind of eyeball my foot switch, see how I'm doing. When I load the steel ball in, this should go to 0, which it did. And let's see if I hit the foot switch. I do. 0.46. Again, on the previous, manual timing data, as I was doing it, if you look, some of the higher drops, I was getting shorter times, which doesn't really make sense. But here, as I'm going higher, my times are getting slightly higher. They're not bouncing around above and below what I was getting before. So again, 0.46. So a lot more consistent. So I'm going to stop and I'm going to restart. 0.47. .45. And 0.45 again. So that's my 5 times for 1 meter. So I'm going to switch now and get my 2 meter stick. And the next height that I want is 1.2 meters, which is 120 centimeters. So 120 centimeters, 1.2 meters. First time at 1.2. 0.49. So again, times are going up, which is good. Seems to make sense. 0.49. Try that one again. Five. .49. .49. So again, on that data set, I had 4 drops at 0.49 seconds. So now I'm going to switch to 1.4 meters, which is 140 centimeters. .40 centimeters. So 5 trials. So whenever you get to a spot where it doesn't reset itself, you just have to hit stop and record again, and hopefully you pick back up. If not, you might have to redo the setup. I don't trust that time. 1.79 seconds seems a bit high, because I wasn't getting 1.79. That I'll buy, 0.53. Because even when I was doing the manual timing, I wasn't getting times like that first one. Now, did you notice before I dropped that said 0.07? I'm going to redo that one because I don't like the 0.07. 0.55. So sometimes when you place this steel ball in here, you'll get a time like other than 0.01. If that's the case, I normally ignore it. And the reason I ignore it is because for the time it's taking this thing to make contact, you know, if I'm not quick enough, you know, that could be 0.06 or 0.10. And if that's the case, it's going to kind of add that to this falling time, the free fall time. So that's why I'm discounting those. So last height, 1.5 meters, or 150 centimeters. We're going to do 5 drops from 1.5. meters, and then you should be able to compare the stopwatch timings with the computer-based timing. 0.55. 0.58. 0.55. 0.54. I'm going to do that one again because if you were watching the numbers, they were bouncing around as I was dropping it. 0.57. 0.57. Okay. So that's all of the data that you're going to need to do the lab. The time average, I'm pretty sure most of, well, should all be able to calculate the average, right? The time accepted, you're going to use the equations in the front of the lab to check that. And then you're going to get, you know, a gravity time or a value for gravity based on the PC times, and the accepted value for gravity is 9.8 meters per second or 9.8 meters per second squared, and then you're going to calculate the percent difference. So hopefully we should be pretty close. Then there is a comparison table on page 9 that you're going to need to complete, and then again another Excel plot. So, and then complete the problems at the back of the lab. If you have any questions, I will make myself available at the Zoom meetings, and stay tuned for the next lab. Talk soon.